So hi everyone, and welcome to the second in the Research Ethics webinar series run by the Center for Biomedical Ethics. For those that missed the first session, we did have some recordings of that we are posting for those that couldn't make it. We are recording this session, as you will see, again for those that aren't able to make this timing. So as those who came to the last session, you'll already have seen me. I'm Owen Schaefer at the Center for Biomedical Ethics. I won't be speaking today. I'll just be chairing the session. I'll be chairing for Jerry, who was introduced last time, and also Professor Julian Savulescu. Same format or similar format as session one. We'll have about 20-ish minutes for the first talk for Jerry to give his talk, and then about 20 or so minutes for Julian, and then we'll have time for Q&A after that. The topic for today is about risks in research, and we'll be focusing on especially some very interesting cases that Jerry and Julian have brought to bear. So I encourage you to, as you're going through, as the cases are being gone through, you can either put your questions in the chat, and we'll return to those after both of the talks are done, or if you prefer, once the two talks are finished, you can use the raise hand function, and then we can call on you that way. I think without further delay, we can begin the session. I'll just reintroduce the two speakers, though, especially for those that might not have been here for the previous session. So first is going to be Jerry Menikoff. Jerry is professor of bioethics at the Center for Biomedical Ethics. He has training both as an attorney and a physician, which, as I always say, is a great combination for doing bioethics. He's worked for many, many years in the field of law and bioethics and oversight. Indeed, before coming to NUS, he spent 14 years as director of the Office of Human Research Protections, which regulates the National Institutes of Health in the United States of America. He has a number of publications, including two books, quite pertinent, one on law and bioethics, the other, What the Doctor Didn't Say, Hidden Truth About Medical Research. Maybe we'll learn some more of those hidden truths today. Julian Savulescu is the Chen Sulan Professor of Medical Ethics at the National University of Singapore, where he directs the Center for Biomedical Ethics. And he's a very, very prolific and prominent scholar in this field. I was just checking his Google Scholar page. It's up to over 900 publications at this point. And yeah, so one of the most well-regarded scholars in our area. And has published on a variety of topics, including procreation, reproductive health, genomics, human enhancement, as well as research ethics and many other topics. Before coming to NUS in 2022, he was the Uhiro Chair in Practical Ethics and the founder of the Uhiro Center in Practical Ethics, as well as a number of other centers at Oxford University, where he retains a part-time appointment. There's many other things, of course, that could be said about Julian as well as Jerry, but in the interest of time, I think we'll move on to the talks. And yeah, we can again save your questions for the end, but feel free to put them in the chat in the meantime as they come to you. Okay, we'll start off with Jerry, and you have your slide deck and you can share yourself, I think.
Okay, welcome everybody. So as Owen said, we're going to talk about risks in research today. And I'm going to concentrate on one particular interesting case. Let's see if I get this. Okay, and so here's what I'm going to cover in the first half of today's session. What are research risks? When is a research risk no more than minimal? So this important dividing line between minimal risk and more than minimal risk. What are the consequences of a risk being more than minimal? And in particular, really going to focus in on what are the research risks in comparative effectiveness trials, randomized trials in which both of the arms, or if there are more than one arm, all of the arms, more than two arms, are all versions of what would constitute standard care. When are those trials, those types of comparisons, when were they considered more than minimal risk? And I'll concentrate on one particular very interesting case study. So let's get started on it. What are research risks? Research takes place when we change what would have happened to the patient for purposes of answering a research question. No changes mean there is no research. Only the changes to what happens to the patient can actually create research risks. And in particular, because this is a somewhat controversial thing that people debate, risks to the patient from their underlying baseline condition, the medical problem, assuming they're in the trial because they have a medical problem, are not research risks. Those risks weren't created by the researchers. So again, this is sort of background stuff. And when are research risks no more than minimal? I took this quote from the ethics guidelines from the Bioethics Advisory Committee in Singapore. Minimal risk refers to an anticipated level of harm and discomfort that is no greater than that ordinarily encountered in daily life or during the performance of routine educational, physical, or psychological risks. This is pretty standard across the world, so not all that different than the US rules. And we're going to be applying this, obviously, to our case. It wants me to go this way. Okay, so let's talk a bit about the consequences of the risks being more than minimal. And there are a number of, narrow, relatively narrow regulatory consequences. First two bullets here are about the Singapore rules. Minimal risk research in Singapore may be reviewed by an IRB through an expedited review process. That's from the Human Biomedical Research Regulations. And for Singapore research involving identifiable human biological material or health information, minimal risk research that also meets other criteria could have the need for informed consent waived by an IRB from the HBRA, their fifth schedule, part 2. Now for US research, the third bullet here, there's a version of what I just told you about the Singapore rules, but it's actually, I guess, more generous to the researchers. So basically what I just told you, there is a way to basically eliminate the need for informed consent, have an IRB waiver of informed consent, but it isn't just limited to research involving like secondary research using biological materials or health information. It's broader and it could apply to all minimal risk research. And it's relevant to the case study that I'm going to talk about. But even in Singapore without those rules, I think there are important points to be noted here. And in particular, on this slide, I'm just talking about, again, without all the special regulatory rules that I just told you about, in informed consent in general, what does it mean to be on the no more than minimal risk side of the line? And from my viewpoint, I hope, we'll all agree on this, telling a prospective participant that a research study involves no more than minimal risk sends them a message that this is the way they should be thinking about it, and from their viewpoint, it doesn't matter much whether or not I enter this study. No very bad things will happen to me if I enter this study. There's no need for me to even think long or hard about whether to be in this study. Just kind of keep that in mind, because that in many ways, I think, is the biggest ticket item here, even if we're not allowing under Singapore rules a waiver of informed consent. So the issue we're going to explore a particular study called support. And the issue we're going to use to explore is, let's imagine we're doing a randomized clinical trial. And if both arms of the trial are versions of a standard of care, in other words, it's what could also be called a comparative effectiveness trial, does it always or usually follow that the trial has no more than minimal risk? And this actually turned into, on the US side, a really extensive discussion of this question. There is a vast amount that has been published. And I must admit, as somebody who sort of triggered all of this, it's very surprising, some of the discussion it's generated. So let's get into it. So let me tell you about the support trial. So in terms of medical background, premature infants often need supplemental oxygen due to their poor lung development. The lungs just, cannot, get oxygen into the body particularly well. And for 75 years, this is dating back to like the 1950s, it's been known that if you give too much oxygen supplementation to the infants, it risks damaging their eyes and possibly actually causing them to become legally blind. That is currently known as retinopathy of prematurity, or ROP. On the other hand, too little oxygen risks the infant's death or permanent brain damage. So the question is there a sort of a best middle in terms of the right level of oxygen to give premature infants? And as of 2005, and actually even as of now, it wasn't known what's the right oxygen level, even though we've actually from time to time done fairly extensive clinical randomized trials on this issue. So let me tell you about support. It was an NIH-funded randomized trial that was determined, to determine this best level of oxygen supplementation, actually conducted there were counterparts in 5 countries, Canada, UK, Australia, New Zealand, in addition to the US. It was designed to enroll 1,300 infants, and they would be randomized to either low oxygen, which is in the 85 to 89% range, or high oxygen supplementation, 91 to 95%. And there were claims, which I'm not disputing for purposes of this presentation, that anywhere between the range of 85% to 95% would be within the standard of care. So a doctor that assigned any of those values would not be committing malpractice. It would be okay for them to do that. Okay, so this trial took place. It ended and it got published in the New England Journal. This is about 2010. And after it was finished, a complaint was sent to OHRP, a U.S. regulatory agency that protects research subjects that I was director of at the time. OHRP initiated an investigation, and in March of 2013 concluded, and went public with this, that the consent, in particular the consent form that was being used, appeared to be inadequate. And there are live links in the slideshow, and we'll circulate this afterwards, so you could click on these. And in particular, the consent form stated that there were no specific risks resulting from infants being randomized to low or high oxygen. And the form suggested that this was a minimal risk study, precisely because both arms of the study were versions of standards of care. And thus, again, quoting from the consent form, there was no predictable increase in risk for your baby. When this eventually got the notice of the media, both the New York Times and the Washington Post had front page stories about this. And the New York Times a couple days later, this was on April 15th, which is the day in the US you have to pay your taxes. It had an editorial, an ethical breakdown, criticizing that the study took place in the way it took place. And what I'm going to now talk about mostly is actually the pushback from all this, pushback from a stellar group of important people in the field of clinical research, including from the bioethics community, which I find particularly, I guess, interesting. So here's the pushback, and a number of items from the New England Journal of Medicine. So, and remember, there was an editorial in the New York Times, April 15th. We now have the NEJM publishing a bunch of stuff beginning only 2 days later. They were really eager to push back. So we have an editorial. This was signed by both the editor-in-chief of the New England Journal and I think 2 colleagues. And again, these are all critical of the government's action in criticizing the informed consent in the study. A day later, 2 very distinguished bioethicists, David Magnus and Art Kaplan, published another item in that journal. And the third item, a couple days later, the director of NIH and 2 of his senior colleagues published in support, a view from the NIH. And these are quotes from what they said. The investigators had no reason to foresee that infants in one study group would have a higher risk of death than would those in the other group. And I just want to point out something that hopefully we'll all agree on this. The use of the would is very, very tricky here. And from my viewpoint, just incorrect. You don't have to know a risk is proven to be required in terms of informed consent to disclose it to people you're asking to participate in a research study. If you are concerned that this risk may exist, you should be disclosing it. So the would should be a might. And in terms of the protocols for the study, and in fact, there was a publication prior to doing this study that discussed why they would do this study. All of them were very clear that the researchers were in fact concerned about the increased of possibility of increased mortality on the low oxygen arm. And this was a key reason for needing to conduct a trial in the first place. Oh, and the final thing, as I noted, so there was another piece in the New England Journal. This is a bit later. You had about 50 of the top US bioethicists, and they really were. I mean, take a look at this. There's another link here. They basically also criticized OHRP and its conclusions. And I'm particularly interested in the quote here. The conclusion that the study's experimental evaluation of these otherwise routinely used oxygen saturation levels expose subjects to additional risk above the risks of routine clinical treatment is not supported by the evidence. So all I want to do now is briefly explain the way you should look at this study, because I continue to be amazed. This is, what, 10 years later, about what we are hearing from the head of the NIH and the editor-in-chief of the New England Journal, and now the top bioethicists in the US. Let's look at what the study did. So let's imagine we're looking at infants before the study comes along. And I'm giving you samples. I don't actually have the actual numbers, because actually the people who conducted the study would not disclose what oxygen levels were being used at the sites in the study before the study took place. There were limits on OHRP's power. We could not, our lawyers would not allow us to force them to disclose this. But the Duke consent form, one of the sites, was very upfront at saying, look, doctors tried to keep infants in the middle of this range. So remember, the range was 85% to 95%. So I've drawn just a hypothetical, U-shaped curve here, bell-shaped curve. And we'll have, again, so this is what the infants might have been getting before the study got conducted. And what was the study trying to do? Here are the two arms that the infants would be randomized to: the low oxygen arm in blue, the high oxygen arm in red. And basically what they were trying to do was exclude the infants from the middle. So putting it all together, the infants started out in the yellow range, that bell-shaped curve, and basically in the study, they were basically moved to the two extreme points. And that's a pretty standard thing that we try to do in clinical trials. You obviously want to show a possible statistically significant difference between what happens in the two arms. So here again, they were taking the infants in the yellow range and moving them to blue or red ranges. And the question is that a minimal risk trial? And so think about that. Again, it was well known ahead of time that the concern on the lower end, the blue range, was these infants might not be getting enough oxygen. They might actually die because the oxygen level was so low, or they might actually have permanent brain damage. Again, there's nothing new discovered in this trial that was a concern, a serious concern. It was spelled out in all of the protocols and in the published design of the trial. On the red arm, the red range, you're at a high level of oxygen. And again, we clearly knew that if you give too much oxygen, wasn't too certain how much, but if you give too much oxygen, you may be increasing the risk of serious eye damage in terms of blindness. So again, you took the infants from the yellow range, the middle, and moved them either to one end or the other end. It was a 50-50 randomization. So you kind of ask yourself, is that the sort of risk that isn't the average kind of daily risk of like a blood draw or something like that? I would claim it's pretty obvious, no, this is more than minimal risk. And yet, again, we have all these distinguished authorities claiming this was minimal risk. Curious what IRBs in Singapore would say about this. So bottom line, in terms of my understanding this, in terms of comparative effectiveness trials in general, it's certainly not the case that studies where each arm is a version of standard of care always involve no more than minimal risk. I think the support trial is a good example of one that, yeah, this is a more than minimal risk trial. You shouldn't have been telling the parents or even suggesting this is minimal risk. Don't think twice about enrolling your infant. It certainly should be for the parents and not the researchers to figure out if a particular infant should be exposed more to the risk, a possible risk, again, not proven yet, of increased permanent brain damage or increased mortality, or instead increased risk of blindness. An interventional study that changes a person's treatment from A to B, even though both are versions of standard of care, may or may not involve more than minimal risk. Sometimes it may involve minimal risk. What if we're studying different medications to treat mild headaches and all of the side effects are minimal? Yeah, that could be a minimal risk trial. So it's going to depend on the differences in the risks of the two versions of standard care. Often such studies will involve more than minimal risk, as I noted, and there's no rule guaranteeing, again, that the reason we reach this outcome is just because there are two different versions of standard of care, that those two versions have the same or even similar risks. That's just not the case. It depends. So let me give you some follow-up on what happened. It was very interesting. So OHRP actually released some draft guidance on this. And interestingly, after this, for whatever reason, the advocates who are saying, well, these studies are always minimal risk because both arms are standard care, they seem to change the conversation. They now avoided discussing support-like scenarios, and the discussion shifted to what seems to me a very different type of study. And from my viewpoint, it's like a unicorn. You don't see many of these around. So let me explain to you why this very different type of study they started discussing is so rare. Okay, so first, one version of this came from, again, the editors at the New England Journal of Medicine, who really, really were interested in this topic, and say, here's the type of study they wanted to talk about now. So they want to consider a hypothetical study. It's interesting how all these studies are hypothetical, comparing treatment of patients with asthma, mild asthma, with low dose inhaled glucocorticoids. And there are a number of these products on the market. So you'd be basically comparing, randomizing patients between two different of these drugs in this class. And let me tell you about another version of this, and you note it's very, very similar. It's just from a bunch of researchers, very prominent researchers, wrote up this proposal, and they were basically going to question IRB members and just random members of the public about whether or not the researchers should be able to conduct certain types of trials without consent. And so here they're talking about treating people with hypertension, and they discuss, okay, let's imagine drug A and B are both drugs used standard care for hypertension, but it just so happens we don't know enough very much about the relative effectiveness of drug A and B in reducing heart disease as a result of reducing hypertension. And let's assume they cause mild side effects that are similar in frequency. So again, similar to what the New England Journal was talking about, the sort of vague kind of and so what they had to do in this sort of survey that they did is they first wanted to introduce people and educate them about, again, members of the public, what is clinical research about. And so it actually showed them this video, this little, cartoon-like drawing. And here they're having, doctors talk about the different ways they could treat people with high blood pressure. And I want to focus in particular, the bottom frame here. And so I've just blown it up a little bit. So there are 3 drugs as you're talking about. And notice these 3 doctors with huge smiles on their face. And they're telling you, well, drug A is good, and B is good, and C is good. All good drugs for treating hypertension. And then after that, they're then going to ask the people, well, would you be okay with being randomized to one of these drugs without their actually even getting your consent? And it worked out that a lot of people would then say yes. And I don't find it actually surprising that a lot of people said yes, because you've just told them about 3 wonderful drugs and they're all good. And these doctors are busy smiling about how wonderful these drugs are. And they've told them nothing about any possible differences among the drugs. And so you have no reason to say any of them is better than the other. So of course, why would you care, which one the doctor gave you? That sounds pretty reasonable, but they've kind of stacked the deck. So what can we say about this? We start out with a focus on research where there were no pre-existing concerns. Well, suddenly we have this focus on research unlike support, where I'd love to redo the slide I just showed you with the three doctors talking about, well, if we do A, oxygen level, your baby has a possibility of having permanent brain damage, or C, possibility of going blind, and whether the parents would say, oh, you could randomize my kid and I don't care. Anyhow, so instead, talking about the ones where there are no pre-existing concerns, two questions you should ask yourself: is this the sort of research we should be prioritizing, where we have no particular concerns about differences between two drugs? And is this sort of research that we actually are conducting a lot of? And I think, no, we actually don't. You go where the money is, where I think there are actual differences. So that's my take on that part of it. And let me just end, final thought. If you're not familiar with what is now getting a lot of play, learning healthcare systems, this is very relevant to what I just told you about, because the approach of learning healthcare systems is that any large medical entity should now be conducting a certain amount of research and embedding it in sort of day-to-day care. And this is a big deal. Beecham and Childress is sort of the classic text on bioethics. They sort of created this field in one sense. And Tom Beecham actually rejected his prior views, the standard views of research ethics, and is a follower of the learning healthcare system approach. And part of their agenda is eliminating the need for informed consent in certain randomized trials, particularly certain types of comparative effectiveness trials. So it's going in the direction of those people who criticized, what OHRP did in terms of the support trial. And just to give you an example of one aspect of the discussion, I actually have a commentary on one of the target articles in the current issue of AJOB, the thing called Canceling Tuskegee. And interestingly, there's an editorial about that target article. And just to show you how powerful and prominent all this is, the lead author in that editorial is the current head of the US FDA. And it's actually pretty rare that you often get somebody like the head of the FDA getting involved in these sorts of controversies, basically pushing this. So I think that is the end of my slides, and and you could email me about any of this, and hopefully we'll have a good discussion. So I'll hand it over to Julian.
Thanks very much, Jerry. That was fascinating, and I'll try and make some comments on the support study as I go along. So I want to talk about risk and research ethics, and I want to show you why ethics is the most important and the most interesting discipline, and that you can't make decisions about these sorts of issues without engaging deeply in ethics. But just to start with a kind of trivial example, some of you may have heard me give before. I mean, what's the right speed limit? I've just come to Singapore, and here the maximum speed limit I've discovered is only 90. In Australia, it's 100. In the UK, 120. In Germany, it's unlimited. Now, which of those is the right speed limit? It depends on weighing different factors. So the safer speed limit is the lower speed limit. So the Singaporean speed limit is safer. The lower speed limit reduces carbon emissions. The higher speed limit promotes economic efficiency. It promotes freedom, pleasure, choice. So which is the right one is a balance of these different factors. And so in the support study that Jerry mentioned, I was aware of this study. I don't actually know what the results were. I was aware of a kerfuffle, but I never wrote on it myself. But I agree completely with Jerry. So I'm not one of those 50 bioethicists who reacted to his decision. I think it's clear that this isn't minimal risk research, but the more important issue is that what was at stake at the very outset was a trade-off between two different values, the value of blindness versus the value of brain damage and death. And doctors didn't know how to balance those. So when they said this all fell within the standard of care, doctors didn't know how to balance, a certain risk of blindness against a certain risk of death or or brain damage. So it was really a question like choosing what the right speed limit was. And what they wanted to do was get more evidence around the figures. But as Jerry correctly mentioned, there was quite a lot of knowledge before that trial started about the risks. And just looking at his 3 different curves without knowing the result of the support trial, if that was my premature infant, I'd want the infant on 90% oxygen, or I'd want to have a discussion with my neonatologist about their view about what was best for my baby. And by failing to disclose the actual state of knowledge at that time, he's completely correct that people did not give informed consent. And as I said, I would have started off my discussion with the neonatologist by saying, why not pick 90%? I certainly wouldn't want 85, and I certainly wouldn't have wanted 95. So I'd be interested to know from Jerry after what the results of the support trial showed. But this was a classic case of trying to balance values. And what doctors did in this study was use these infants in order to get better knowledge about the risks, to make it clearer what the option should be. But there is no doubt that for some of these infants, it wasn't in their interest to be a part of that trial. And as I said, if I was a parent of one of those children, I would have been doing my own research. So what really matters in trials like this, I mean, Jerry focused on the consent issue. So one thing that matters, just to go back, there's 2 jobs. Basically, ethics committees do 2 things. They ensure that harm is prevented or minimised, but I'm going to argue that their key role is to ensure that it's reasonable, and that people give valid consent, that they're informed, they're competent, and they're acting freely. Now, in Jerry focused on the fact that these people weren't actually informed of the relevant evidence at the outset of the trial, and that's correct. I'm going to focus on this other issue about whether the risks that infants were exposed to in something like the support trial were reasonable. And just if you want the take-home message, I think reasonable risk, to decide whether a risk is reasonable for a participant, whether it's an infant or an adult, is reasonable, is determined by 6 factors. So first of all, is there a known risk prior to commencing the study based on evidence that's available? So what do we know about the nature of the risks? Should we be doing more research that doesn't involve exposing the participants to risks, either by using animals or computer modelling or AI and so on, to gather more information before we commence the study? Is the risk reduced to the smallest amount possible? So, for example, in the previous study, what I would be looking at if I was on an IRB evaluating that protocol is, how did they pick those boundaries for low and high risk? Could they have been narrower, or could they have been closer to the 90% level? The fourth factor is there an alternative which involves less risk but has the same expected benefits? Now, most importantly, are the potential benefits to the improvement of welfare of trial participants, or more usually future patients of this study, worth the risks? And then are there dual use concerns about the generation of risk to other people outside of research now or in the future? So I'm going to give you this even older example than the support trial to illustrate the issues around evaluating whether a risk is reasonable. Actually, before I do that, there is this declaration of Helsinki that is extremely influential for IRBs, that says a physician shall act in the patient's best interests when providing medical care. And there's a further statement that while the primary purpose of medical research is to generate new knowledge, this goal can never take precedence over the rights and interests of individual research subjects. Well, my contention here is that in the support trial, the drive to get knowledge did override the rights and interests of research subjects, at least those that were exposed to the extremes of those distributions of oxygen. Now, I think I'm now not going to talk about what might even be called minimal risk research. I'm going to talk about what is risky research, clinical trials. And although this is a very old example, it applies to all clinical trials. So the fact that I'm using a study from the early 80s is irrelevant. And the reason why I'm picking this trial is this is often held up as the paradigm of how to conduct good research using randomized controlled trials. So I want to take you through this and show you how massive assumptions were made about what constitutes reasonable risks and how the interests of trial participants were subjugated to the drive to generate more medical knowledge. So back from the early 70s, it was known that thrombolytic drugs reduce total mortality from acute myocardial infarction. And in 1982, the first meta-analysis of a number of trials was performed, which showed that thrombolytic drugs reduced mortality from acute myocardial infarction. In 1984, an Italian trial, the GIZI trial, randomized 11,000 patients to either streptokinase or placebo. And in 1985, a large meta-analysis showed that thrombolytics reduced the risk of death by approximately 20% with a p-value of 1 in 1,000, less than 1 in 1,000. So it was less than 1 in 1,000 chance that 20% figure was incorrect. Okay, so by 1985, many studies, a GIZI study with 11,000 patients already underway, and we have evidence that streptokinase is better than placebo at reducing myocardial mortality by 20%. So in 1985, the ISIS-2 trial, primarily based in Oxford, was commenced. And it ultimately randomized 17,000 patients to streptokinase, aspirin, both or neither. Now, while that trial was being conducted, the GIZI trial showed that streptokinase reduced mortality by 18%, with a p-value now of less than 2 in 10,000. Right, so roughly equivalent to the 20% figure. Nonetheless, the ISIS-2 trial continued, and in 1988, it showed that streptokinase reduced death by 23%, with a p-value now, what is that, less than 1 in 100,000. So 43 randomized controlled trials brought the total number of patients randomized to 21,000. So I calculated that over the span of the ISIS-2 trial, 238 more people in the group receiving placebo died up to 5 weeks after acute myocardial infarction. So I think it's reasonable to ask, why was the ISIS-2 trial started? Didn't we know that streptokinase already worked before the trial commenced? So you will often be told, we don't know. So that in the support trial, doctors didn't know what the right level of oxygen was. But knowing is a value judgment. And here it's a value judgment about how confident you want to be or need to be that streptokinase is superior to placebo. So in January 1987, remember the streptokinase trial, the ISIS-2 trial randomized about 17,000 people. But after just 4,000 patients, the data monitoring committee said that they had proof beyond reasonable doubt that streptokinase reduced mortality in hospital from 12% to 8%. So the steering committee made this statement that, and remember, another 13,000 patients went on to be randomized, and half of those were given placebo. Now, the reasons given for continuing was that it wasn't known how long these effects might persist. It was not known whether there are identified categories of patients who will or will not gain significant benefit from streptokinase, and it was not clear whether the benefit was dependent on how early a patient presented after the onset of patient. But so given that around 200 people died, how can we justify the continuation, indeed the commencement of such a trial? So here are some possible justifications for why the trial was started and why it was continued. The first of all, we want to know what the truth is about streptokinase. But there is no such thing as truth in medicine. There are only higher and higher degrees of confidence. So what you did was increase your confidence that streptokinase was better than placebo. Richard Dole, probably the world's most famous epidemiologist, who was the chair of the Data Monitoring Committee, he identified the link between smoking and lung cancer. He said explicitly, as chairman of the Data Monitoring Committee, I made clear that if I had a myocardial infarct, I wanted to have both treatments, that's the aspirin and streptokinase. And this is after the 4,000 patients had been randomized. So Dole said he would want to have streptokinase, yet people continued to be randomized from that point to drive the p-value down from probably 1 in 10,000 to 1 in 100,000. And so Richard Dole gives 2 reasons for why these large clinical trials are necessary. The first is to provide much more evidence that's much more readily accepted by clinicians, and as a form of continuing medical education. So just remember that, of course, it's good to have medical education, and it's good that we encourage clinicians to accept treatment, but people die to provide that. So was it necessary that 200 people die to provide those endpoints? So according to the trial participants, all extremely famous epidemiologists, Rory Collins and Richard Pito, the design of randomized controlled trials should be governed by the uncertainty principle, or clinicians' equipoise. So this is that patients can only be entered if the responsible clinician is substantially uncertain as to which of the trial treatments would be most appropriate for this particular patient. Now, equipoise is largely a myth. There wasn't equipoise at the start of this trial. There was a lot of evidence that streptokinase was superior to placebo. And as Richard Dole said, there was proof beyond reasonable doubt after 4,000 patients, and he would want the treatment. So if clinicians are uncertain, they're just irrational. So this is trading on an epistemic weakness of clinicians to justify continuing to enroll patients. The real justification for continuing trials like this is really utilitarianism. So again, Dole said, unnecessary obstacles to randomization or to large numbers may lead to many thousands of future patients being inappropriately treated. So you can do numbers on this. I don't have time to go through these examples, but the larger the trial, the more confident you are that the treatment is beneficial and the side effects are tolerable. And when it is rolled out to millions of patients, if you were to make a mistake, many people would be affected. So the reason that you do large clinical trials is not in the interests of the participants, at least not, from at least some early point in the trial. It's for future patients. It's to protect large numbers of future patients. That's why you want to have a p-value of 1 in 100,000. But is 1 in 100,000 enough or too much? That, again, is a value judgment like the speed limit. So here's the Declaration of Helsinki. Concern for the interests of subjects must always prevail over the interests of science and society. That is just garbage when it comes to large clinical trials. The interests of the subject are always likely prejudiced once you cross some very early statistical threshold, like a p-value of 0.05. And even at the outset of the ISIS-2 trial, it wasn't in the interests of patients to receive placebo. And indeed, nowhere in the justifications that Dole, Pito, and Collins offer do the interests of trial participants appear. It's really to do with the massive numbers of people that will receive treatment. Now, you could say, why don't we just return to sort of the conventional level of statistical significance, a p-value of 0.05? That would be more in the interest of trial participants, but it would expose large numbers of future patients to much higher risks of receiving a treatment that was inferior or had unacceptable side effects. So, you heard this statement. I remember when the AstraZeneca vaccine was released, you heard this statement that it's safe and effective. The trials were conducted on, I think, around 15 to 20,000 people. So safety there means it hasn't had an undesirable side effect profile when given to 20,000 people. It says nothing about what the side effect profile is going to be when it's given to hundreds of thousands or millions of people. So it wasn't surprising that the problem of brain clots emerged. And then people said, oh, the drug isn't safe. But safety involves a value judgment like the right speed limit. It's a balance in the case of the vaccines between the desire to save lives from COVID versus trading off side effects. You could ask patients what levels they think, what levels of statistical significance they think are acceptable. And there are different ways in which patients might choose according to different distributive justice principles. But that's not what's done. So it's interesting that only 400 patients in the US were recruited when 6,000 were recruited in the UK. And indeed, if the US had recruited at the same rate, the trial would have finished 6 months earlier. But I think the reason that it was difficult to recruit patients in the US is that doctors are much less inclined to apply a utilitarian principle and to use their patients for the sake of future patients. So in fact, they were probably more concerned about the interests of their patients. So I think we should replace this concept of nominal efficiency with the concept of reasonable risk. I haven't actually said that the ISIS-2 trials are not justified. The ISIS-2 trial wasn't justified. I've simply tried to show you that it involves massive value judgments about the value of knowledge and the protection of future patients versus the interests of trial participants. And that trade-off is present in every single clinical trial. So when you're told we need to have a certain level of statistical significance, for scientific reasons, that's nonsense. It involves value judgments that make these trade-offs. So I think let me finish there and leave some time for questions.
Thanks very much to Julian and Jerry for those very interesting and I think challenging presentations. So we have time, as I said, for Q&A now. Again, you can either type your questions into the chat or you can use the raise hand function. I'm getting a few in the chat and I'll just turn to those, but feel free to use the raise hand function if you'd rather raise your questions verbally.
And I could respond to Julian's questions about support while we're waiting.
Yeah, go ahead if you want to quickly respond to that.
Sure. So to be fair to the researchers, what they hypothesized is that actually if you go from 90% oxygen and gradually decrease it down to somewhere in the 80s, that there wouldn't be an increase in mortality or permanent brain damage, that you basically could reduce the risk of blindness without seeing an uptick in the bad things happening due to lack of oxygen. So that's what they hoped. So exactly, Julian's correct. It's about a trade-off. They didn't think there'd be much of a trade-off. You'd basically be able to lower the oxygen level and not see much more bad things happening to the people. They were wrong. It worked out on the low oxygen end. There was an uptake in mortality. I don't remember exactly how much. Might have been like 3, 4, or 5% increased mortality. But in general, the editorials afterwards viewed that as unacceptable. So it's like nobody's certain now what the trade-off should be.
Thanks so much for clarifying that. Okay, we have a question. There's one question in DM and one question in chat. I'll go for the question in chat from Joel Sia. Would it have been acceptable? Would have the support child been more acceptable if the parents were informed of the risk, were informed of the possible risk? Could they have answered the research question without the child? So, for example, instead of doing a randomized trial, could they have just done prospective review of medical records instead of running the trial, right? Or is it if they had, is there an inherent problem other than the consent process essentially? What do you think, Jerry?
Yeah, no, good, really, really good question. I mean, I don't have a problem. I mean, I tend to sort of, believe informed consent protects the research subjects, ultimately even more than the IRB determining what are acceptable risk levels. So if indeed they informed, there's a big debate about whether this trial should have taken place, and OHRP never said it shouldn't have taken place, and I've never certainly said that. So yeah, if the parents were fully informed and they were okay with what was happening to their kids, I'm far more open to that. In terms of now whether you could have better designed it and sort of kept half the infants at 90% and just randomized to the low end, for example, the different ways of minimizing the risk trade-off that Julian was pointing out. Those are other ways you might want to actually do it. But in terms of trying to learn what you wanted to learn just from looking at the data out there, I think that would be very, very, very hard to do. That's why we keep going back to, randomized trials as like the gold standard. Even with this trial and even with several prior trials that were randomized over prior decades, it's just really, this is a rare event, the infants going blind. And it's just, there are so many things happening. It's just hard to tease out, the oxygen versus the blindness and brain damage, et cetera. So I don't think, you had a lot of smart people trying to answer this over many decades, and I think you really needed a good clinical trial.
Thanks for that. There was a private message sent to me that is raising a question of risks. It was a bit broader than maybe the specific trial protocols we've been discussing. But this question is sort of about actually relating back to the COVID-19 pandemic. And thinking about the way risk trade-offs were done in that context. So the question there is, well, and there's, now there's a pandemic treaty being negotiated for future pandemics. So even if we think this pandemic is over, there's questions that are raised for future pandemics. So yeah, just about how we think about these risk calculations in pandemic contexts. So one example was about, for example, intubating 2 patients using one shared machine and risk of cross-contamination, but maybe just more generally. About evaluating maybe research protocols post-COVID. Are there any lessons in this regard?
Well, I think that the biggest challenge of risk is to properly communicate it and enable people to understand the reality of the situation. We live in this kind of Hollywood of certainty of, things are either safe or they're not safe. I mean, even take Owen and I were discussing this, the sort of radiation from Fukushima. These involve value judgments around the level of, risk you should expose people to. And, people say, oh, it's a scientific judgment. It's not a scientific judgment. It's partly scientific, but it's also partly about people's values in relationship to, say, blindness versus brain damage. So I think one of the challenges is to move away from these kind of categoricals that, no one is safe until everyone is safe. We're all in this together, to trying to understand the different values at stake and being honest about how you're, balancing them, and where you can enable people to make their own decisions about balancing risks. But, sometimes governments have to make a decision that, there will be lockdown or vaccines will be mandatory, but they need to be clear about the trade-off between the values and the risks involved. Because I think now you can't hide behind paternalism and you can't hide behind people's ignorance, because they will find out. As indeed this individual who complained to Jerry found out that actually they weren't told of the reality of the situation at the outset of that support trial.
Thanks. And yeah, I just have a self-plug in the link there to the idea of pandemics and ethical trade-offs and the treaty. It's very important, I think, that the treaty that's being negotiated does what Julian says and acknowledges these trade-offs. Sorry, Jerry, did you have something to
Yeah,
add on
no,
this?
and just picking up on that, right? Exactly what Julian was saying about utilitarian thinking, and COVID-19 is a great example of that. And comparing what happened in the UK in terms of the recovery trial, if you ultimately want to do the best for the most people, you certainly, in the face of a huge pandemic like that, want to learn the answer in terms of what treatments should be used as quickly as possible. And in the UK, they pretty much kind of enrolled people in clinical trials to test that. In the US, that didn't happen nearly as much. And that was probably because, again, in the US, there's a sense of the doctors doing what's best for the patient in front of them. And the question is, should we be tweaking our research ethics? And that's pretty much what, like, the people promoting learning healthcare systems are pushing for. Let's kind of be more attuned toward right, allowing more research more quickly, but diminishing the rights of some of the research subjects that we won't always get their consent.
So I think, I didn't get to give the sort of second part of my talk, but there is a kind of consent is one value, and maximizing benefit, minimizing risk is another value, and sometimes you have to trade these. So sometimes, I'm not averse to restricting consent. It's just you have to be explicit about why you're doing it and what the other values are.
Thanks. There's a question from DPR Chen. Well, maybe it's just a comment, but reflection on it. So, one concern is that if you kind of fully inform patients, maybe in the support trial, that about all these risks, that recruitment numbers might drop. Now, maybe that's that's an unfortunate reality. But how do we grapple with that? How should we react to that potential reality?
Yeah, that's the huge elephant in the room, and which gets into the issue of, well, right, how utilitarian are we in terms of trade-offs between what we think, different types of rights people had versus ultimately, saving the largest number of lives, whatever. And that is we should have a more open debate about some of this. That's part of the problem with support. They just kind of reduced the quality of the consent without actually having changed our rules, and have society doing what it does to sort of change different types of laws, rules, whatever it is. So that is a core issue. I totally agree with that. Yeah.
So Joel has a question in the chat, which I just would like to quickly address before we finish.
Yeah, go ahead.
So Joel says, if I got your conclusion right, how should IRBs go about balancing utilitarianism versus patient autonomy in terms of looking at the risk-benefit ratio? So my main point is that this is not a scientific issue. It's an issue for ethics committees, and there isn't a formula to it. You're going to have to make your own decision about how to balance utilitarianism versus patient autonomy. One thing you should do, though, is as Jerry said, ensure that where we're obtaining consent, people do understand the reality of the existing evidence, and why the trial is being conducted, and have the ability to form their own beliefs about what's best for themselves or their child. But there isn't a formula to balance utilitarianism versus patient autonomy. I'm not suggesting that the ISIS-2 trial was unjustified. It was just a very, very utilitarian trial. But that's okay, as long as society understands that that's what's happening, and that people are being exposed to risks, and they have the opportunity to try and find those treatments outside of the trial. So unfortunately, ethics doesn't come with a sort of kind of recipe book and a sort of magic set of answers. There is a lot of grey, and that's what I've tried to do, is to show you actually the ethics is much more important, and your role as ethics committee members is much more important than you might ordinarily be told, particularly by clinicians and scientists.
Yeah, thanks. And I do think this is one of the areas of ethics review that is has the most discretion for every member. So contrast that with consent. There actually are regulatory requirements of all the things that need to be in the consent form and how the processes work. And there's still disagreements over that, but at least it's in black and white. Whereas you look at regulations around risk and benefit, there's very little, structured guidance or requirements, right? I think in Singapore, area, there's not even a requirement that the benefits outweigh the risks aside from in any particular way. And yeah, so it is an area that that requires ethical reflection and deliberation. And that you have to hopefully be applying some of the principles that are done here, but it will ultimately come down to IRB and researcher discretion. But I hope the discussion today is helpful to especially IRB members and also researchers and research support staff in those deliberations and understanding what's at stake, and that these are not just technical questions but ethical ones as well. So we're just at time now, so I'm going to again thank the speakers and thank the participants for your questions and engagement. As always, feel free to send us any comments or feedback or further queries. You have our contact details from the registration. But there's going to be 2 more sessions in this series in 2 weeks and then 4 weeks. 2 weeks, I'll be giving a session on scientific validity and scientific value in research and that aspect of research review, which is another part that's sort of outside of the regulatory directive space, but requires a lot of IRB judgment. And then in the 1 month's time, we will have a session on, I think, inducement. And Jerry will come back for that, and also Dr. Sumitra Menon on payment for research subjects and some recent, maybe not like consensus, but shift in the ethical landscape in that area that we're interested to share and get other people's perspectives on. But otherwise, I think we can close the session there. So thank you, everyone, and have a good afternoon.
Thank you for your questions.
Bye-bye. Yeah.